Singular point means at which point function is not analytic. That is called a singular point. And not analytic meaning, analytic definition already we know that function is differentiable for every point of some neighborhood of A. But that is not possible for verification every time. So we can go by this method at which point function will fail. That is called a non-analytic point, singular point. Otherwise, points are analytic. That is the meaning. Isolated singular point. Isolated means only at that point, only not analytic. Remaining everywhere. Or every neighborhood also you can write. Function is not analytic only at z is equal to A, then that is called isolated. Means analytic everywhere except A. So here I wrote function is analytic everywhere on deleted neighborhood of z is equal to A. Okay. Otherwise you can write except also can write except z is equal to A. Both are same. Here one thing. Every right, huh? Otherwise maybe you will think some or anything. Every neighborhood. Every deleted neighborhood, every here also, every neighborhood. Or here we can write is analytic everywhere except z is equal to A. Like that also we can write. Non-isolated singular point. Non-isolated two type you will see. Sometime you will see that neighborhood of A, at least one point you will get, every neighborhood. At least one point you will get, their function is not analytic. Non-isolated means except itself. Sometime you will see at A analytic have, but neighborhood of A analytic not have. Sometime both you will see. Some function at A also does not exist and neighborhood of A also does not exist. So both I am writing. Both cases non-isolated we will count. So non-isolated singular point of f of z, when f of z is not analytic, at least one point of every neighborhood of z is equal to A. Or not analytic at z is equal to A and not analytic at least one point of every neighborhood of z is equal to A. Only neighborhood writing means that is every only. No need to write especially. But maybe will come confusion. Example, some neighborhood they will put. That time you will think every or some sir gave only neighborhood. So what is this problems will come. Any place neighborhood writing means that is every only. Okay. Hereafter we will see types of singularities. Right first. Pole. For pole we need isolated singular point. When our singular point will exist order, order writing means finite only. Order does not exist means that will go essential. Okay. Here also I dot m. So when any single isolated singular point existing order, finite order, then that is called a pole. Okay. Next, removable singularity. For removable singularity also we need isolated singular point. An isolated singular point is called a removable singularity when limit exists. Means limit z tends to a fz exists. This meaning we can remove that singular point and we can tell after removing this is analytic function. That is called a removable singularity. Means at that point anyhow fail will go. Okay. So fail will go means which type of fail will go means limit possibility have existing. Maybe functional value fail going, limit exist type, just removable discontinuity type. Means we can, if we are feeling this at z is equal to 0, 0 by 0 form, infinity by infinity form, in that case you will see that we can remove this point and we can make our given function is analytic function. So that point is called a removable discontinuity. If direct at that point limit does not exist going infinite and all coming, then that is called a, with order that is called a pole. If order does not exist, then that is called essential. And here you see, I'm not writing, only I'm writing singular point. Here isolated, non-isolated, both possibility. Any singular point, if order does not exist, if we are feeling, then direct tell this is an essential singular point. After that essential singular point, two types, isolated and non-isolated. isolated essential singular point. So when isolated singular point, non-isolated we are finding, then we have to take help by limit points. Direct is very tough to find. Hmm? Sometimes this is easy also. We can tell that isolated singular point with order infinite, then that is called a isolated essential singular point. Because essential means order does not exist. Order is infinite will go. In that case, we can tell like this. Like this. Okay. So we will go by the help of limit point. Limit point, we will find sequence of zeros of f of z. Whatever given function f of z given have, we will find zeros. Zeros means root. Means f z is equal to 0 we will do, and all roots we will find. Roots will come in the form of sequence. So that sequence of zeros of f of z limit point we will find. Whatever limit point will come, on that limit point only you will see isolated essential singular point. Means that point you will see no order. Order does not exist. Okay. Non-isolated essential singular point. Here limit point we will see sequence of zeros of g of z. Same only. Sequence of zeros of g of z is called a non-isolated essential singular point. But what is this g of z? This g of z is a denominator function of given function f of z. Means just like you can think g of z is equal to 0 means whatever point will come of g of z, that is a singular point of f of z. Correct? Zeros point of g of z, at that zeros point fz will fail, no? Infinite will go. So that also we can tell. But we want limit point, so I'm writing like this. Limit point of sequence of zeros of f of z, g of z is called non-isolated essential singular point. G of z is the denominator function of given function f of z. Okay. This is singularities all types. Singularities, all singularities this only. But don't think these are easy. If you will practice definition under your control have, then this is very easy. If you will forget definition, you will get confused, pole, singularity, everything mixing, then this is very tough. Okay. But don't confuse. We will see example one by one. By example only, we can clear our all types. Sometime singularity point order we can tell direct. Then that is called a pole. Means pole order, sometime direct we can tell, sometime can't tell. So order, how to find for pole? Is just we will verify, means z minus a power 2 into f of z, suppose 0 came, then power 3 we will try. We're still getting this m, just you think list positive integer at which power m into f of z not equal to 0 coming, that is the pole of order m. Okay, but every time formula, by my experience, you no need to use formula, direct we can tell. That type question will come. Very rare you will feel, if you have good practice, means very rare you will feel we need formula. Otherwise direct we can tell order. Last class I gave now how to find order of zeros, order of roots of f of z. I gave, I think, this class only, last class. Which power derivative we will verify at that point not equal to 0, that is the order of zeros of f of z. Write this. Here after example we will see. Function 1 by z. So 1 by z function will fail at 0 itself. Except 0, no any problem. So 0 is called a singular point. Also only at 0 will fail. So isolated singular point. Okay. Order we can find Z is equal to 0. If order existing, then this is called a pole. So order how to find? We can go by formula also. Formula given have, by formula we can find. But before formula, just you think here power 1 have. So simple. Power 1 means simple pole. Okay. Here we can write Z is equal to 0. Isolated singular point of order 1. We can write Z is equal to 0 is a pole of order 1. Pole of order 1 means that is called a simple pole. Order 1 is always simple pole, simple 0, everything. Simple word we will use only for order 1, either pole or 0. Here power 1 I told and I did like this. But we can go by formula also. Limit Z tends to 0. First power 1 we can use Z into f of Z. So 1 comes to 0. So pole of order 1. So by formula also we can go. Just we are doing practice. Exam hall direct we will do. No need formula and all. Suppose fz is equal to 1 by z square. So power 2 have pole of order 2. Here we can write z is equal to 0 is a isolated. Everywhere analytic except 0. Isolated singular point of order 2. If we will go by formula, also same not equal to 0 will come z square. So direct this power 2 we will see and we will tell. So this is called a pole of order 2. Like that, anything if we are getting like this 1 by z power n for all n belongs to natural number. This is possibility that pole is possibility for essential. Because exam hall they will ask which type of singularities and at one point different name will come. Maybe they will tell pole also and essential singularity also. So any type of pole, essential singularity possible or not. What? What is essential definition? Order does not exist, means order won't come. Pole means order had to exist. So not possible. Tell pole never will become essential. Finish. Okay. Right. 1 plus 1 by z. In this case also z is equal to 0, essential singularity isolated singular point of f of z of order 1. So we can write here also this is a pole. Like that we can increase next power. Suppose z is square. Same we can write z is equal to 0. Direct we can tell here of the pole of order 2. Whatever degree you will see, that is the order. Sometimes they will skip some power. Direct, they will give power 4. So 4 itself a order. Direct we can write pole of order 4. So finally, suppose we will see like this going on any power m. So we will write z is equal to 0 is a pole of order m. Suppose this going on continuously, no break till infinite. Then what is the order? Infinite. Order does not exist. This is an isolated singular point of order either does not exist, right, or order infinite, right. So this is an isolated essential singular point. Okay, right. fz is equal to z. This is the entire function. No, it's seeing only. Yes, no, anything tell. Yes. Not reading. This much red alert came. Red alert time what did? Huh? Red alert time, you are maybe still yesterday red alert going on. Not coming, no, you are. Then, what doing then? Reading only. What reading? Real. Complex not reading. And then, that only I'm asking, this is entire function or not, silent leaving everybody. Entire function. This function is not analytic at which point? Infinite. Extended complex plane. So z is equal to infinite and only at infinite will fail. So we can write this is an isolated singular point of order we can tell order is 1. How can tell order here? Then what will come? When I told that and all, I am asking pole. What is the order? This is pole or not? When infinite you are finding order or anything, no? Here order 1 is you are correct only. But we can't give explanation by theories or anything. Anything can't talk. Order 1, right? No problem. But how you have to go just opposite. This function we can change any type of singularity. If we are going to find pole, then what is the pole formula? Order. Sorry, we are going to find order of pole. I gave formula limit z tends to a, z minus a power m, but a is the finite value, not infinite. So for infinite, I'm asking this is the order existing or not. Order exists means this is a pole. So what is the order? We can't go by that formula here. Because that z tends to a have no, a is the finite value. So we can go here whenever infinite any concept we are finding, just opposite. Opposite means 1 by 0. 1 by 0 means 0. 0 is our point. So this function, inverse function we will change. Just you think, let z is equal to 1 by w. Means z plus 1 by w we will put. So our now this function will come. Just you think g of w. Just 1 by z function. And hereafter w is equal to 0 only singular point. When infinite is a singular point means 0 is a singular point for inverse function. Okay. So here we can write w is equal to 0 is a same isolated singular point of order. And hereafter same concepts direct only we can go. Order here power 1 have, so order 1. But here by formula we can apply. Just now 1 by z I solved, no? Just 1 by z we can find like this. But here we can't do, no? So by the help of 1 by z I can tell about z. So here order is 1. So here also same concept will go. Here power 1 has order is 1. Here power 1 has order is 1. Either any singular point. Okay. But theoretically if we are going, subjective we are going, then we have to explain like this. Okay. So w is equal to 0 isolated singular point of g of z of order 1. So finally we can write z is equal to infinite is an isolated singular point of f of z of order 1. Subjective means like that you have to continue. Okay. And finally, this is a pole. So Z is equal to infinite is a pole of f of Z of order 1. So we can tell this is a simple pole. Okay. Same if order, if we will increase wire. So same we can write Z is equal to infinite, then isolated singular point. Subjective exam means this type direct don't write. You have to change and have to explain till here. Okay. Of order 2. So here we can write this is a pole of order 2. Same Z power n, anything for all n belongs to natural number, is a pole of order n. Right. Ah. Hmm. Ah. Now this is for zero. No, for order that z minus a must want, because for singularity will be in denominator, so that cancellation need. For that z minus a power m into f of z. Like that we can go any type of power given have polynomial function, same infinite is an isolated singular point of order. Here 2 will come. Okay. If we want to change by z is equal to 1 by w, we can change here also. Like that will go 1 plus 1 by z plus 1 by z square, and same we can write w is equal to 0 isolated order 2. Okay. In this case, no order does not exist. So infinite is a infinite, right, or does not exist, right? Anything, right? Already infinite have will get confusion. Does not exist, right? Order does not exist. So we write isolated essential. Okay, right. whatever function with us have, every function we can make in the form of series form by the help of binomial expression or another any expression. And that expression we can change in the form of Lorentz series, every function. So Lorentz series, last class I gave this is. From that we can explain and we can write like this. This is the final Lorentz series. In Lorentz series you can see two type of series are there. One z minus a have in denominator, another one in numerator itself. So when this is have in denominator, this is called a principal part. And this is called analytic part. Analytic series, polynomial form. Okay. You can see here this series going till infinite. So z is equal to a is isolated singular point of order does not exist. So we can tell z is equal to a is isolated essential singular point. Right, I have no place. Right first everybody. Lorentz series, this, from this explanation they are asking question, this theory. Okay, Lorentz series is very, very important. More question coming. Lorentz series next chapter also some residue chapters, some theories are there. So this theory itself, this explanation itself 2 times, 3 times recently they are. So don't neglect. Don't think only we will use for formula, not like that. They are giving different M and they will ask. Sometime in Lorentz series itself, this and principal part they will fix anything. We can go. Don't think Lorentz series means only infinite will go, not like that. This is series, anything we can fix. So just now we saw know that 1 by z, any type of function already we saw. Plus z, Lorentz series, analytic part. 1 z plus z square plus 1 by z. Analytic part plus principal part. Principal part is this. So 0 is a pole of order 1. Okay. So they can mix anything and they can give z is equal to 0 is a pole of order 3, analytic part, principal part. And not only 0 form, anything they can give 1 plus 1 by z minus 1 plus 1 by z minus 1 whole cube. After that z plus z square plus z cube, like that they will give. Principal part plus analytic part. Z is equal to 1 is a pole of order 3. Okay. Right. So every function, every complex function we can find in the form of series. And in that series, either we will get only principal part, we will get only analytic part, we will get mixing principal part plus analytic part. This only Lorentz series. Okay, right. fz is equal to sin z. Sin z is analytic function, entire function everywhere. So this will fail at infinite extended complex plane. So z is equal to infinite of order. What is order? Who is telling? Oh, you are. Infinite. Does not exist. Why does not exist? Why have to expand? Without expand, you tell. Without expand, if want to tell means we have to change in 1 by z form. That is common concept, 1 by w. Okay, and at w is equal to 0, we can find. But there also we need expansion. Okay, you are correct only, just I want to listen. So here we can't tell polynomial type that z have power 1, z square have power 2. So sin z power 1, that type don't think. So sin z, if order want to know at infinite, so we have to expand only. So sin z expansion, remember how? Tell. Won't tell. You tell. What name? Vishali. Tell. Either you tell or silently. Or you are telling her. Huh? Huh? What telling? Odd power will come. I don't know. This type. Okay. So if we will do expand completely, then this will go till infinite. So degree till infinite going on. So order does not exist. Order infinite we can write. So we will tell z is equal to infinite is an isolated essential singular point. Okay. Another way we can find any singularities here. I told you just now without expand I want. Then what to do next? 1 by z. But there are also expands and want to know. Anyhow, w equal to 0 expansion only need there also. Without expand, there are also one solution. You are true only. But I want this fully expansion separate. When order, suppose we can't find order told infinite means essential we are going, correct? This is confirm have essential, this is. Essential, okay, leave it. This question leave it. Without expand, question you are not understanding, leave it. Okay. Essential singularity, isolated also I told. If I am not going by expansion, not going by expansion, then how to find isolated singular point? Isolated essential singular point. Basic principle part. This is full analytic part only. No principle part here. Isolated essential singularity definition I gave. That tell everything I have to tell clearly, openly, then will give answer. Exam hall mark sheet, answer key, everything will come. We will go zeros method. We will find zeros of f of z. Sin z is equal to 0 means z is equal to n pi. So we will get sequence. So this is a sequence of zeros of f of z. What is the limit point of infinite? So limit point of zeros of f of z is called isolated essential singular point. So z is equal to infinite is an isolated essential singular point. So suppose you are getting any confusion here, order infinity or does not exist, then you find zeros and you can go it. Okay, right. One by sin z. So here after sin z have in denominator. So singular point possibility at zeros point of sin z. Correct? So here we will direct zeros point of sin z. Means denominator. Denominator I told no g of z, that only. So here we have to go direct zeros point of denominator only. Because zeros point of f of z we can't find. So same. This is sequence of zeros of g of z. Here one question they can ask your previous question. Sin z is equal to 0 have z is equal to n pi. Means we have infinite number of zeros. So they will ask how many zeros are there. And what is the order of zeros they will ask. So you continue there. Now I am writing order of zeros. your previous question continued. Order of zeros of f of z at z is equal to n pi. So order how to find, just we have to check derivative. So here your previous question fz is equal to sin z. So we will do just derivative. First derivative will be cos z and we will check at n pi this is non-zero or not. So non-zero only f dash n pi, if separate if we will go pi 2 pi 3 pi minus 2 pi. So this will come minus 1 plus 1 minus 1 plus 1. So anyhow non-zero only. So they can ask with you order. So we can tell that all are order 1. First derivative is called a non-zero. So order 1 means simple 1. Sorry, simple 0. So we can write z is equal to n pi for all n belongs to integer are order 1 zeros, right? Zeros of order 1. So all n pi are simple zeros of f of z. Every function, different question options they will ask. So you have to write everything. Write that first your previous question. This write everybody now. This derivative method common, real analysis, modern algebra, any place, order asking for roots, zeros for function, just derivative method. Okay? Don't think complex only. So here, whatever zeros point have g of z, that is the singular point. So we can write that f of z has infinite singular points. Also we can write isolated for every n, pi 2, pi 3, pi, these are only non-analytic point. Respectively. So infinite number of isolated singular point have for given function f of z. Sometime domain also they are giving. and they will tell how many singular point inside domain. That we will see later. Okay. Leave it. When we will see again, I will explain. Only function given have, you can tell infinite number of. Domain means just maybe they will give center is 0, 0, radius is 10. Center 0, 0, radius is 10. Then how many singular point total? This function has 10 singular point, 20 singular point, like that they will ask. So whatever your n pi have, whatever will contain here, you can write. Pi means 3.14 something. So I think pi will contain 2 pi. 2 pi also will contain 3 pi. 3 pi will contain 9 point something will go. So same here 3, here 3. Means total 6. 4 pi won't contain. 4 pi means 12. 12 point something will go. So between minus 10 to 10, 3, 3. Total 6 points. So they will tell domain given means f of z has total 6 infinite, as total 6 isolated singular point. Okay. So domain giving means little extra you have to think. Like that I will explain later also. So this singular point order will exist. Means all a singular point. Now what is the order? What is the order of pi, order of 2 pi, order of 3 pi? Already we saw this all are order simple zeros. Okay. So if we are finding pole definition, then pole also simple pole only will come. Okay. If we are going, suppose z tends to n pi, z minus n pi, power first I am trying into f of z. F of z is 1 by sin z. Anyhow, 0 by 0 form. So we have to use L'Hospital rule. L'Hospital means derivative with respect to z. So this is 1 and this is cos z. So anyhow coming there only we are. So 1 by cos n pi. Just minus 1 power n not equal to 0. Integer, right? No problem. Pi, 2 pi, 3 pi. This power will be same. Here I am right. No problem. Both places n and using natural number. Okay. So power 1 itself not equal to 0 coming. So we can tell all infinite number of singular points are pole. Simple pole. Pole of order 1. Okay. Right. So function has infinite number of poles, infinite number of isolated singular, but different name they are giving in option. Infinite number of singularities, infinite number of poles, infinite number of simple pole. Like that different they will ask. Another any type of singularities we can find from here. We can find, limit point of sequence of zeros of G object denominator. What is the limit point? Same infinite. So Z is equal to infinite is an isolated. How isolated? At infinite, this is infinite is not a infinite is analytic point. Sin infinite is infinite. Constant by infinite 0 exists. Non-isolated will come. Non-isolated. Limit point from denominator function. No? Zeros then isolated. Zeros from function then isolated. Here will come non-isolated. Essential singular point. So this is another type of singularity. Every function have more type. Every types singularities have to find. Right. Sin 1 by z. So 1 by z means same we will go by binomial expression. So z is equal to 0 is a isolated. So 0 is an isolated singular point. So with this we got by binomial expression. Another one concept we can get from zeros of f of z. So f of z has infinite number of zeros. Order 1 we can find by derivative. Simple only will come because derivative of sine 1 by z is cos 1 by z and minus 1 by z square will come. Simple zeros can write. F dash 1 by n pi non-zero will come. And this is the sequence of zeros of f of z. So limit point what is the limit point? 0. So 0 is already isolated essential we got from there, and by definition also limit point of zeros of f of z are isolated essential. So we can write by definition also finally 0 is an isolated essential. Right. 1 by sine 1 by z. So if like that have this meaning, this is denominator function. So direct we can go zeros of denominator function. This we no need. Hereafter binomial expression, nothing will work here. This don't want. So just you think direct zeros point of denominator function of f of z we will go. So just everything same we will tell for denominator function. So here sequence of zeros of g of z, limit point will be 0. So sequence are coming from denominator function and limit point of denominator function sequence. What we will tell? Non-isolated essential singularity of f of z. Okay. Another any type of singularity, and all are order. For this is order. This is the order of zeros. Essential we are getting at 0. Can I tell 1 by pi means 1 minute? Any mistake have? No, correct have. This meaning 1 by n pi singular point of given f of z. That explanation I have to give. Okay. Here we will write z is equal to n pi for all n belongs to integer are infinite number, because zeros point of denominator function means that is a singular point of given function. Also isolated we can tell 1 by pi, 1 by 2 pi, all are isolated. So isolated singular points. Order 1 only. These are a simple zero of denominator function. Then must order 1 will come. If we will find pole by pole formula, must order will come. Singular points of order 1. Respectively, everything. All are order 1. If suppose you want to go by definition, then we can go definition also. Limit z tends to 1 by n pi, z minus 1 by n pi into f of z. F of z means sine 1 by z. After that same only will come, no? L'Hospital rule, 0 by 0 form. L'Hospital rule will come is this is anyhow derivative of that g dash z. Correct. Here we are writing, no, g dash of 1 by n pi not equal to 0. Here also same only will come. L'Hospital rule one time itself, here 1 will come. 1 by derivative of this. Can I write this type? The g of z function z and g cos 1 by z and into minus 1 by z square. So here will come z square cos 1 by z. Anyhow g dash of 1 by n pi is non-zero. So here also this is the non-zero only. This only will come, anyhow non-zero. Simple pole. Okay. So we can write z is equal to 1 by n pi for all n belongs to integer or simple, just infinite number of simple pole, infinite number. F of z has infinite number of singularity, infinite number of simple pole, like the different they will ask. So infinite number of simple poles of f of z. Understood? Right? Start from here. Huh? Start from here, complete zeros, and we can go by sequence of zeros also. So 0 is a non-isolated essential singularity. After that 1 by n pi, you can write like this. Right, everybody? Here also write respectively. Yeah. Where? That point is isolated, no? For all natural number respectively, no? Respectively, I am writing last. Every 1 by pi means every n will give one isolated singular point. 1 by pi is isolated, 1 by 2 pi isolated, 1 by 3 pi isolated. That is the meaning. 1 by pi, any neighborhood, if you will choose nearby. For all infinite neighborhood, we can choose. So there you will see only at 1 by pi, that is not a singular point. Understanding? If you will take extra more big neighborhood, means 1 by 2 pi, 1 by 2 pi, 1 by 3 pi will contain, but that is different concept. But 1 by pi, we can closer to 1 by pi, infinite neighborhood we can find. There at 1 by pi only singular point will come. That is the meaning isolated singular. For all neighborhood of that point only. Right. All are isolated for all integer respectively. All, it's not only one. That point is isolated. That point neighborhood, no singular point. Analytic everywhere. That is the meaning. e power z. Analytic functionally, entire functionally, so z is equal to infinite. Also order will go infinite, so no order. We can write an isolated zeros. We can't find zeros, not possible. So okay, enough this is e power 1 by z. Here also we can't go by zeros, but binomial expression we will go means z is equal to 0, we will get essential singularity. Another anything? No, zeros we can't tell. Only one type of singularities can tell. Enough. Right. Sin z by z. This is very common function for removal. There discontinue also, singularity also. Z tends to 0, f of z existence will come. So 0 is a removable singularity. Okay, and we can remove means how to remove? Just we will go binomial expression and we can remove. Analytic part hereafter. So now this is analytic function. We removed. Okay, so in this function changing means analytic getting, but in this function 0 by 0 form at 0. Okay, so 0 is a removable discontinuity, sorry, removable singularity we can tell here. Right. Tangent we will see. Very important function, more time came. Tangent means just sin z by cos z. So here zeros also we will get, denominator zeros also we will get. So we will start from zeros of f of z. So Z is equal to infinite, isolated also, non-isolated also, both. Means that infinite also will fail and neighborhood of infinite also, every neighborhood of infinite fail. Okay. Another anything we are getting, these are zeros of denominator function. Tell this number of isolated singular point of f of z. Also order 1 will come. All are simple zeros will be there here. Cos z, no, next sin z will happen derivative, so non-zero must will happen. Okay. So all are simple zeros of cos z. So simple pole of f of z. I have no place. You write one time, again I will write. Here you can see infinite both coming, isolated, non-isolated. Sometime like that more function you can get maybe. At same point, two type of, yeah, isolated, non-isolated, or means two type, more than one type of singularities name will we get, name you will get. Okay, more example gave. Now I am writing same type of cos series and all you finished. So some example question giving, later practice too. Okay. How much you will practice, that much this confusion will clear. Otherwise, you exam hall you will get confused. How this is, how that is. Enough. But you try to go by books also. Books also more question have find. What discussion started? Time getting means I started another topic. Meromorphic function meaning function is analytic in that domain D. Except possible poles. Means possibility have if pole existing also meromorphic function we can tell. No other singularity. Means function either analytic on that complete domain D, either within, on, whatever domain given have. If any singularity are existing, then that singularity possibility only pole. Then we can tell meromorphic function. No singularity, other singularity existing, not meromorphic function. So either analytic or analytic with poles. That is the meaning. So for that, accept possible poles. Whatever domain given have. Okay. So more example already we saw. We can tell that entire functions are analytic everywhere in C. So entire functions are meromorphic function. Whatever domain can define, everything we can tell. Every entire function. Are meromorphic function. On in D, right, in C, right, complex plane. Suppose I will write 1 by Z, or any domain I will define unit disk. So we can tell meromorphic, analytic everywhere, and pole is 0. So this is meromorphic function on this D. This is meromorphic function. No. Why? Yes. This is not meromorphic function. Like that only. Already more example we discussed. You can choose meromorphic who is not meromorphic. Okay? Right. Which type of singularity is here? This much explanation I gave, also problem coming. Where pole have? Z is equal to 0 is a pole of order. Another? Correct. Z is equal to infinite is a pole or essential? Essential. Who told? Pole only, no? Of order 2. At infinite fail will go because of this. Degree is 2. Okay. What happened? Little confusion what I will. Why confusing? Analytic part, principal part both have. No, analytic fail at infinite only. If degree fixed have, then pole. Degree not fixed have, then essential. Principal part. Degree fixed have, then pole. Degree not fixed have. Essential. Every time this will happen. Going on. Infinite, pole, order 2, 0, essential. Finish. Okay. Get confusion, change in 1 by W form. Z is equal to 1 by W. Then here 1 plus 1 by W plus 1 by W square will come. 0, what is pole of order 2? So at 0, W is equal to 0 is a pole of order 2. So infinite is a pole of order 2. Correct. Reverse will go. That time this is W plus W square will come. Then f of 1 by W means this is analytic function, that is principal part. Huh? So this always will happen. Generalization can't write, otherwise two type explanation have, because both are infinite go it. Analytic part also infinite, principal part also infinite. So we can write both cases essential only. How I will write then? If they will fix that 1 to something, then only we can tell order, otherwise essential only. Yes. At Z is equal to A and Z is equal to infinite respectively. Can write A also essential, infinite also essential. If they will fix, then infinite is a pole, A is a pole. This already I wrote just now. In z minus a power n minus n, and this also a power, suppose here r writing. So if they will fix here, then infinite is a pole of order m. Lorentz is like that, more question asking there, and z is equal to a is a pole of order r. Okay. Finished understanding? Confusion went or not? Not going. Revision to automatic will go. Preparation for tomorrow test going now. Real matrix linear. Preparation not have done, tell me, I will cancel test. Preparation do and write test. Next Sunday write. That is no problem. But time past I don't write. Tell me, huh? If you are ready for writing tomorrow, then no problem. Want extra 1 week time? Prepare and tell. Then next Sunday I will put test. Okay. Preparation test don't write. We will see next residue. Time came. I thought 11:30, 12:30 approx. Morning type only I was feeling. Chillness type, I chill have no. I thought morning only going up. 1:45 came. Okay, after lunch. After lunch here after.